Man, check this out. This is awesome. Are you ready to hear the sweet sound of victory? The upgrade I made in my first video revealed a problem in the Z-axis, a vibration. And before I could fix that, I wanted to install this new water-cooled spindle so that any fix I made on the Z-axis vibration would translate through to the new spindle. So now we've accomplished all that, and today we're going to fix that Z-axis vibration once and for all.
First, let's be clear about what was actually happening. When the Z-axis moves up, the motor lifts the spindle and the threads stay tight. But moving down is different. Gravity does most of the work. And with the weight of the spindle, gravity was winning. At first I thought something might be loose. I checked the bearings and cleaned them. I checked alignment and shimmed everything properly. Everything looked fine once I was done, but the problem continued. That's when it hit me. Nothing was broken. The system was just unbalanced. Like some people I know. Here's the lead screw, and here's the nut. Moving up, everything stays engaged. Moving down, gravity pulls the spindle. If gravity pulls the spindle down faster than the motor is traveling, then the nut unloads from the screw. That tiny gap, that's the growl, and that's what causes the vibration.
Before I show you how I fixed it, I'm curious if you've ever chased a problem that turned out to be something simple like this. If you have, go ahead and drop in the comments. I'd love to hear about it. And I read them all.
The new spindle didn't cause the problem, but it sure did amplify it. More weight means more downward force. More force means more unloading. And more unloading means more vibration and noise.
So for anybody that says it was because it was dirty, nope.
Before installing the dampener, I had one more issue to address. The tool plate from the last video had a design flaw. Originally, the tool plate that held the router brackets had recessed bolt holes, but my new bracket didn't, and the material was too thin to put any. So I used it as a temporary placeholder to finish the spindle mounting. It worked for cutting the redesigned tool plate, but it wasn't right. And if I was about to increase the load on the system, it needed to be right. So I redesigned the part and cut a new plate out of 1/2-inch aluminum.
Okay, well, we've reached the moment of truth. Here we are with our water-cooled spindle mounted temporarily while I attempt to machine the new tool plate, the 1/2-inch thick one that'll have the recessed bolt holes. I got the water hooked up temporarily. Got water flowing, so we're good there. All of this is just temporary till we get things permanently hooked up. So let's touch off the tool and crank up the spindle. Alrighty, crank up the spindle. Alright, well, it's going to force a tool change because that's what it does. Whoa, that sounds horrible, huh? Tool change.
and with the recessed holes in the thicker material, the bolt heads finally sat flush. And now, with a new and improved tool plate and spindle installed, I could finally turn my attention to the Z-axis. In order to fix the problem, what I needed was constant upward pressure. Something that pushes back against gravity at all times, like this shock. I took the time to design the shock mounting system before I cut out the new tool plate. And when I did, I marked the screw hole locations with a V-bit. And then I drilled them to tap size on the drill press. I also marked and drilled out the holes in the shock support tower to receive the rivets that would secure the shock mount on the far end. Then I did the same for the end that mounts to the tool plate. With all that accomplished, it was only just a matter of assembly. I simply rivet the shock mount to the tower, and then install the tower onto the tool plate with screws. Then I just snap the shock into place. This hydraulic shock applies controlled upward force through the entire travel. And now, when the Z-axis moves down, gravity doesn't get to have a free-for-all with my machine. No unloading, no gaps, no vibration. So here we have the finished product. And that solved it. Listen to this. So much better. Same machine, same settings. The only difference is the shock. Nice and smooth. And the growl is completely gone. And that is the sweet sound of victory. Setting a finer resolution on my stepper drivers for smoother motion may have revealed the problem, but it didn't cause it. It wasn't dirty bearings or lead screws, and it sure wasn't the spindle. It was gravity the whole time. Once I stopped thinking about parts and started thinking about forces, the solution became obvious. And now that we've finally conquered the Z-axis vibration problem, it's time to finish the spindle upgrade properly. That means permanently wiring the VFD, securing it in an enclosure, and getting coolant flowing. But we'll take care of all that in the next video. If you want to see how this whole vibration problem started, I've linked the first video right here. If you've enjoyed this video, just remember, CNC fever is real.
Go ahead and hit subscribe. Yeah!
But treatments are available. Thanks for watching. We'll see you next time.